Hello, we will be presenting the reverse dosimetry and PBPK prediction REVK case study on pharmacokinetics modeling using PK-Sim on the Jaqpot modeling platform. This is work done by Padalis Karajas, Philip Doganis, Agilos Valsamis, Georgia Tsiliki, Haralabot Sarimveis at the National Technical University of Athens. Presented here by Philip Doganis. So PK-Sim is part of the Open Systems Pharmacology suite developed by Biopharmaceuticals. The code has been recently made available as open source. The big power of PK-Sim is that it allows you to move from substance to rat to an individual human to a human population and make assessments about the effects of drugs. We'll have a brief overview of the pharmacokinetics workflow that we will use. First, we will start out with a PBPK model in XML format already developed in PK-Sim, and we will make that available as a web service. First, we need to have a data set that contains the physiological parameter values that were used in PBPK model development in PK-Sim. It looks like this. It provides information about the age, height, and weight. And we will integrate that PK-Sim model into Jaqpot and make it available as a web service using parameters that we will take a look at later in more detail. And we'll use the model to obtain drug concentration time profiles, make predictions about that, about a certain data set that we will use that contains other physiological parameter values for PBPK model predictions. It will be similar to that. It will contain age, height, and weight combinations for which we want predictions. This is the Swagger interface for the Jaqpot API. It is an easier way to understand the functionality of a dataset, and this is what we will be using. First, we need to have the age, height, and weight data that we saw before, and we will use that. We will do that using the post the dataset create dummy dataset method. We need to provide the CSV file that contains the data that we saw before on the slide, a title and description of our choice. By clicking Try It Out, what we get is a view of our dataset in JSON format, who created it, when it was created here, and the age, height, and weight data that we saw. As a second step, we will use the biokinetics PK-Sim create model, the post method here, and we need to provide the dataset URI, the file, the XML file that was created in PK-Sim, a title and description of our choice, the algorithm URI that shows us the URL of the PK-Sim algorithm, and parameters that will be used needed for the model, which will be what we saw actually before. It's the age unit, which will be in years, the height unit in meters, the weight unit in kilos, and the drug will be theophylline. So if we click Try It Out and wait, we get a task ID, and if we query that using the get task ID method, we'll see information about the course of the task, and we'll finally see, okay, the model has been saved and the task has been completed successfully. And what we get is this model, the PK-Sim model, is available now as a URI, which means that now we can use it to make predictions. If we choose the model, the post model ID method, then we can provide an input dataset that contains different height, weight, and age values. We provide the model ID, and clicking Try It Out, a new task starts. And by clicking the Get Task ID method again with a different task code, we see that the task has been completed successfully. But now what we get is a dataset. This dataset contains the predictions for the drug concentration profiles over time, and we can use the Get Dataset ID method to query the dataset, either in JSON format or in CSV. Let's take a look at the CSV format this time. And this is what it looks like. We have the predictions for the drug concentrations for different time points. We could take a look at that as JSON format as well. It is harder to read actually, but contains more information. That concludes the presentation of REVK case study with Jaqpot.